I sat in the audience yesterday and listened to two NHS doctors talk about the strains that they feel on the job and how there are rota gaps and how they work 15 hours on a 12-hour shift and feel like their personal lives are stretched razor thin to meet the demands of the healthcare system. And when I think about AI and healthcare, I certainly don't think about replacing any of those people in the heroic efforts that they're going to on a day-to-day basis to make the NHS work. I think about really a productivity boost for those doctors to help them do better. I'll give you just a few examples. One is medical imaging. We saw the pictures of Malamutes and Siberian Huskies. There's no reason you can't turn the same set of technologies to diagnostics from MRIs or CAT scans or pathology slides. Another example is natural language interface with computers. Right now, there's lots of differences between the UK and the US. In the US, time and motion studies of doctors show that both GPs and hospitalists alike spend up to a third of their time doing manual data entry into an electronic health record system, which to me seems like a colossal waste of their talents when they could be practicing medicine rather than doing clerical work. Why not Dr. Alexa, right? A medical database coupled with a natural language interface that could allow doctors to speak aloud patient notes and diagnoses and have those immediately committed to a medical record. Now, I don't want to understate the incredible engineering and data science challenge of getting that kind of system in place, but that's okay. Future is a long time, and I think that it's worth making those very, very kind of ground level roots investments in data science and AI technologies in healthcare for maybe this generation, maybe future generations to see the payoff. If you think of the investment that the British taxpayers in the late 1940s made in the NHS and the fruits of that investment that you are bearing today, this is the opportunity to do the same thing for future generations.
But we're not doing it.
Not nearly as much and not nearly as quickly as I reckon we ought to be doing.
And why do you think that is?
That is an incredibly complex set of issues. One certainly is engineering and mundane data plumbing issues like the interoperability of databases. To some extent, it's frustrating. It's like Nightingale all over again. When I deal with hospital systems in the US, it's not that they all have different classification systems for disease. At least that problem has been taken care of. But they certainly have their own idiosyncratic software vendors for electronic health records. And I want to merge data from GPs with data from the obstetricians in the hospital to help build a better prediction tool for stillbirth or neonatal death. And of course, I can't get the systems to talk to each other. Never the twain shall meet. So that's part of it, is the colossal engineering challenge that involves. And that is a question of time and money and effort and a public commitment by everybody involved. I think another part is fear. And a kind of worry about data privacy. And I think that is a very real, very trenchant, very important concern. I will say a couple of things about data privacy here. We live in a year where data privacy has come to the fore with scandals about Facebook and Cambridge Analytica and all that sort of thing. And I think it is essential that the machine learning and AI communities do the best that they can to restore trust in the bedrock principle that nobody's data will ever be used against them or without their consent or in ways that they didn't give permission. That has to be a bedrock principle of the age of AI. At the same, this is much more important for healthcare data than it is about what brand of dog food you shop for online, right? This is way more important for healthcare data. A couple things to say about there. One, there are technological solutions to this. AI and machine learning researchers think a tremendous amount about data privacy. And there's a whole class of algorithms that we could talk about for hours called differential privacy algorithms. The core of these algorithms is the idea that you can store data in such a way that no individual record could ever, in principle, even mathematically ever be linked to any individual human being. And yet, in the aggregate, the collection of data that you build up can still be used to train prediction rules and artificial intelligence systems for finding patterns in data that might be used, for example, to get better instantaneous diagnoses from medical imaging, or to build early warning systems for sepsis or hospital-acquired infections on the ward. And those algorithms, I mean, there's all sorts of, there's a mathematical bag of tricks there, right? They go by names like cryptographic hashing or noise injection. It's a huge research area. There is a technological solution to these privacy problems. Needless to say, no healthcare system I'm aware of is using them. They tend to be way behind the times on IT. They're not IT professionals, they're healthcare professionals, right? So division of labor is important here. The other thing to say about privacy is the moral issue. I understand a squeamishness about healthcare data being pooled and shared and analyzed by algorithms, by software. I personally find that less creepy than it being looked at by human beings, but there can be a difference of opinion about that matter. I will also say, however, that if your squeamishness about that issue extends to a prohibition against it ever happening, even under terms that can guarantee your individual privacy, then fine, make that decision, but you should make that decision with a clear head about the trade-offs, about the economic trade-offs, about the immense sources of social and financial value that sit in the healthcare databases of the world, and about the moral trade-offs, about the same moral trade-off you would make if you withheld your kidney from the organ donor registry, that when somebody else needs that kidney, well, guess what? Somebody else needs the data on your kidney function as well. So it's not as direct a life saved as when you donate a kidney. It is much more diffuse, but that's why it's important that we all do it and that we all come together and recognize how important this decision to pool and analyze healthcare data is. This is something, by the way, that Great Britain is more poised than any nation on earth to do. In the US, our healthcare system is so screwed up and there are too many vested private interests that you don't have to be much of a cynic in the US to point out that for-profit healthcare systems make money on advancing chronic disease. And so what is the incentive to build AI systems to prevent that? And on the continent or other nations that have public healthcare systems, full public healthcare systems, the way that the UK does, there's not the cluster of information technology and expertise in machine learning and AI. Great Britain can be the nation that does this. I mean, think of all of the gifts to healthcare that Britain has given. You invented liver transplants. You learned about DNA. You gave us the National Health Service. This can be a gift to the world that you give, a model for how information technology and AI can be used to improve healthcare. And I'll be sad to be sitting on the sidelines back home in Austin, Texas when it happens, but I'll be delighted for the human race if you do it.